Hey everyone, welcome to video number 3 on lesson 9, the radicals and conjugates. This is the guided video notes. So the last two examples are a little bit different, and it has to deal with the number that's right kind of snugged in on the square root, or the root here, the radical, and it's not the square root, it's the radical here. And that 3 indicated it's going to be a cube root. Down here, notice the number 6, it's a 4, that would be a fourth root. So we're going to start this and handle this the same as we did the previous examples. Okay, where we take 72 and we're going to prime factorize 72. So we're going to start there, and I'm going to break this down. I'm going to go to 9 and 8. And I'll tell you the big difference here, what we're going to try to do. So 9 breaks down into 3 times 3, and those are two prime numbers, so that's done. And sometimes you can circle these if you want. 8 breaks down into 4 and 2, and 4 breaks down into 2 times 2. And this is the key right here. Before, where it's a square root, we want powers of 2. With a cube root, we want to try to write everything we can in powers of 3 to match that index if possible. So what I'm going to do here is I'm going to go ahead and rewrite 72. And I'm going to write that as we have 1, 2, 3. So 2 times 2 times 2. That's going to be 2 cubed. Okay? Times 3 squared. Now, I got to remember to put that 3 out here now. Okay? Now, let's break down the variables. Okay, so let's look at, well, if we take x to the 12th, okay, this time instead of like the last example we divided by 2, if we take 12 divided by 3, that gives us 4. So that's what's coming out. So you're going to have an x to the 4th out here. Okay, and I can show you why in a second. And then if you look at y to the 8th, okay, y to the 8th, and if you divide that by 3, so 8 divided by 3, you get 2 with remainder of 2. Okay, so you're going to have y squared come out, but you're also going to have y squared underneath. Okay, so to simplify this the rest of the way, you're going to have x to the 4th, y squared, times the cube root. Don't forget that 3. Okay, I got to bring that 2 out. The 2 comes out. See how the power on the 3 is less than the index? That has to say, so 3 squared is 9, and the y squared just stays the same. So that's our first example. Okay, now let's look at example number 6, and we'll show you a couple ways to break down the variables if you don't like that division. So this is a fourth root now, fourth root. So I want everything that's underneath the radical to try to be raised to the 4th power if possible. So here's 80. And we're going to break that down into 10 and 8. 10 breaks down into 2 times 5. And 8 goes to 4 times 2. And then 4 breaks down to 2 times 2. And notice under here we have 1, 2, 3, 4. And that's all multiplied together. Remember, if I wanted to write this, this is 2 to the 4th. Okay, 1, 2, 3, 4 times 5. That's what 80 is equal to. Okay, so let's go ahead and set this up. So we have the 4th root. Okay, and that is really crooked. So we're going to go 2 to the 4th times 5. Okay, and we're going to look at our variable x squared now, and x to the 10th, and we're going to divide that by 4. Divide that in, so 10 divided by 4 is equal to 2, and you're going to have 2 left over, so R2. So watch what happens. We're going to have, on the outside, okay, we're going to have the 2 come out, so there's the 2, and I just said we had 2, 4 goes into 10 twice, so x squared comes out, and then we're going to have a squared inside. So let's go ahead and draw that 4th root sign. 2 to the 4th is out, 5 has to stay, it's a power of 1, so that stays, and we have x squared inside there. Y to the 12th, well, y to the 12th, okay, 12 divided by 4 is 3. Okay, so nothing stays underneath, everything comes out. So we're going to have now 2x squared, y to the 3rd power times the 4th root of 5x squared, and we are all set. So that's just a couple more examples on simplifying radicals, okay, that are more than square roots. This was a cube root and a fourth root. So if you have any questions on this, please don't hesitate to ask, and we'll see you next time.